Mr. Minnick here, teaching my students how to do binary addition and then some other numbering systems to follow on this worksheet. Let's review number one and see why the answer worked out to be the answer. Well, I recommend that you line up your addition problems vertically, even though on this worksheet they are written horizontally. Somewhere on the scratch paper, please show your work. So let's redo number one. 10001 lined up with 101. Notice I do not say 101 because these are binary numbers. They are not meant to be pronounced the way a decimal number would be pronounced. Hey, this is pretty easy. 1 plus 1 is 2. Wrong. You can't have a 2 in your final answer for a binary problem. In the world of binary, they only have zeros and ones. So you have to think about it. When you get 1 plus 1, yes, you get the number 2, which I'll write down over here in the margin. Now, how many groups of 2 can you pull out of 2? 1. You can pull out one group of 2. So that one group that you pulled out of 2, one group of 2 that you pulled out of 2, you represent it as a 1 in the next column. It's called carrying. And you learned about this in, say, first or second grade. But you did groups of 10 back then. Now you're doing groups of 2. Now, what do you get as a leftover when you have a group of 2 that you pulled out of 2? Oh, you get a 0. So the leftover amount is written carefully here. And now you continue. What is 1 plus 0 plus 0 in this second column? Well, that's easy. That's a 1, and that is legal and binary. Hey, what's this 0 plus this 1? 1. So that's legal. You did not need to carry anything. Now we carefully look here. This 0 is lined up with nothing below it, so it just kind of takes a placeholder position there. And this 1 gets added to the imaginary 0 below it, so it just kind of comes down here in the final answer. There is your final answer that matches up with the answer I already provided. If you're a fussy person, you'd put a little subscript 2 here to show everybody that's not the number 10,110. That is not the number 10,110. Either put a 2 here, or just know that because of the context of this worksheet, all these numbers in this section are meant to be binary. So Minnick does not need the 2 there in your final answer on this particular worksheet. Okay, let's do another binary question. I don't want to take away any of these that are on the worksheet. That's just fun for you to do at home. So I'm going to make up a problem here, like 111 plus 11. Hey, let's add some other numbers, like 101. And what the heck, let's throw another one in there, like 10. 4 binary numbers all added together. Let's figure out what this is. I add up this 1 plus 1 plus 1 in the ones column, and that's a unofficial 3, which we cannot put in our final answer, of course, because 3s are not allowed. But you ask yourself, how many groups of 2 can you pull out of 3? One group of 2. So you represent that one group of 2 by putting a little nice 1 there. And how many leftovers do you have after you pulled out that group of 2? Let's see here, 3 minus 2. You have 1 leftover. So that leftover amount goes down there. And now you proceed to the next column. This next column is not called your tens column like it is in normal math. It's called your twos column. I'm just saying. Anyway, in the twos column, let's add up all the ones that we have. Well, 1 plus 1 plus 1 plus 1, that's a grand total of 4. Well, 4 is not a legal binary digit. You can't put it down here in your final answer. But you can, over here in your scratch paper area, whoops, sorry about that, let me put that back. In your scratch work area, you can say, hey, how many groups of 2 can you pull out of that 4? 2 groups of 2 can be pulled out. So put a little unofficial 2 up here. Even though 2 is not allowed in your final answer, as a human who learned decimal, you can put a 2 up there. And after you pull out 2 groups of 2, what are you left with? Well, you're left with 0, because 2 groups of 2 is 4, and 4 minus 4, you're left with 0. So you do have to put the 0 leftover amount down here as a placeholder. And now we're in this next column, which is called the eighths column in official binary numbering. In the eighths column, you have this 2 plus this 1 plus this 1 for a grand total of 4. So over here in my scratch paper, 4. We're done with this scratch work. How many groups of 2 can you pull out of that 4? 2 groups of 2. So you have to carry another 2 over here to this new column that didn't exist before and subtract 2 groups of 2. In other words, subtract 4 from that 4. You get 0 again, so you have to put that 0 as the leftover amount down there. And now you have this new 2 being added up with nothings. You know, I think that people that do binary, well, not think, I know, they tend to they pad their numbers with zeros, leading zeros, just to keep everything lined up. That's just the style in binary. And if you want to, you can think of this as being an imaginary 0 here, here, and here. So now we're left with, what is 2 plus 0 plus 0 plus 0 plus 0? Well, duh, that's 2. Oh! I can't put a 2 in my final answer. The teacher almost got his own problem wrong. I can't put a 2 there. I have to ask that repeated question, how many groups of 2 can I pull out of that 2? Well, one group of 2. So you put a 1 in yet another new column over here. How many leftovers do you have? 0. So you've got a 0 there. It's kind of messy here, but placeholder. And now this one gets added to all the imaginary zeros that we have out here in the, geez, what column are we in? Let's see, let me count from right to left. The 1s column, the 2s column, the 4s column, the 8s column. Yes, John Quill, claim to fame, it's the 16s column. You made my YouTube video with a good answer. So I'm in the 16s column and I have a 1 there. So anyway, that 1 trickles down here, and that 1 is legal in my final answer. So there is the final answer to that made-up problem, which isn't on this worksheet, but it's just good learning. All 4 of these binary numbers, when added together, make this binary number. Now that we did a couple binary examples, I'm going to erase all that scratch work and do some octal addition problems. This tends to be easier for students because octal is closer to decimal in a way. Let's review number 11 here, 3 plus 5. Well, 3 plus 5, that gets you the total 8, which is illegal as a final answer in octal, because octal only has the digits 0 through 7. So you ask yourself, how many groups of 8 can you pull out of that 8? 1. So you put a 1 over here and you carry into the next column. How many leftovers do you have after you subtract that group of 8 out of a group of 8? 0. So you put a 0 there. And this other column, just that 1 trickles down here and makes a 1 in your final answer. So there's the final answer in octal. Don't say the number 10. Don't say it as 10. 10 is a decimal name for something. It's just pronounced as 10, assuming that we're in an octal world where maybe Martians have 8 fingers and they count in groups of 8 instead of groups of 10. Okay, let's do another octal problem, but let's not do one of these. Let's do a crazy, complicated one here that has like 3 or 4 numbers in it. Ooh, 777. That's a big octal number, kind of like 999 in decimal. Now let's add the small number 13 to it, and let's just throw another number in there like 450. I did not say 450. Ooh, this is going to be long and complicated. I'll try to fast forward here, and you can pause it in YouTube. Well, I add up the 7 plus 3, and I get a group of 10. How many groups of 8 can I pull out? 1 group of 8. So that 1 comes up here in the next column. I have a leftover 2. So that's where I am so far. Okay, now that I'm in the 8s column in this octal number, I'm in the 8s column, not the 10s, the 8s. 1 plus 7 plus 1 plus 5. That adds up to 14. But you can't put a 14 down here. And you don't put a 4 and carry a 1 or a group of 10, no. You ask yourself, how many groups of 8 can you pull out of 14? One group of 8. So you put a 1 in this column. You have a leftover 6. So the 6 goes down here in your final answer. And now we're in the last column here. 1 plus 7 plus 4. That's a group of 12. Again, we can only pull out 1 8 out of a group of 12. So a 1 goes into this new column. And we have a leftover 4. And this lonely 1, he trickles down here and adds with a bunch of zeros. And there's your final answer, 1462, to that made-up question I just put in the margin of this worksheet. That is not due for homework because that's not an actual worksheet question. Hey, the columns in an octal number from right to left. This is the ones column, and we've already said that this is the eights column. Who can raise their hand and loudly tell the video, other than John Quill, who already answered earlier, what is this next column called, the third column in an octal problem? Yes, this next column right here, the third column in, is, as Tristan said, the 64s column. Good job. Now the next column, I have a student in this room that's not even in my Java class, Haziel. Haziel, what's the next column? The fourth column in an octal number from the right to left is the 512. It's the 512s column. It just sounds ridiculous, but that's what it is, because it's 8 to the third power. 8 times 8 times 8, which somebody said was, Haziel said was 512, so I'll take his word for it. Any questions from my current class on octal? Okay, folks, this might be the longest video some of you have ever watched in your life, at least YouTube style. Patience is a virtue for learning. Let's look at my hexadecimal section of this worksheet and review the one sample problem that's there. 12b plus f3. We've already learned to count in hex yesterday, so having letters in here should not surprise you. But how do we handle it when we add? Well, b plus 3, duh, that's tricky. So let's make a cheat sheet. Somewhere in the margin of your paper, remember that in hex, a is equal to the normal decimal number 10, and b is 11, and so on. Don't be afraid to do this on your scratch paper, because not a lot of you have these letters memorized, but you will have to make use of them in these problems. 0 through 9 in decimal are the same as 0 through 9 in hex. So I normally don't put that on my cheat sheet. I just put 10 through 15. Okay, now so really b plus 3 is really 11 plus 3. Think of it in your decimal brain as 11 plus 3, which is 14 in decimal. How many groups of 16 can you take out of 14? None. Look at this. 14 is a legal digit, but you can't write it here as a 14. You have to write it, according to your cheat sheet, as an E. So there's going to be an E in the final answer right there in that column. This is weird, but on some planet where they have 16 fingers, and they go around counting in groups of 16, unlike Earth where we group in groups of 10, somewhere on some planet, it's common to go say b plus 3 is E. That's just kind of, in a weird way, that's what they think of. Okay, the next column, there was nothing to carry there. Now we're in the next column, the 16s column, and we have 2 plus f. Well, to you and me, that's really 2 plus 15. See, 2 plus 15, f is 15. So that's really a 17. Are there any groups of 16 that you can take out of a group of 17? Yeah, one group. You end up being having a leftover 1. So the leftover goes down here as before in octal and binary, and that one group of 16 is represented as a little 1 that we put up here. And now we're ready to move to the 256 column. And we have a 1 plus a 1 plus an imaginary 0 here. Yeah, that's really a padded 0. So 1 plus 1 is 2, and 2 is a legal hex number, so we're done. Okay, now are you folks ready? We're going to do a harder hex problem, one similar to problem 10 here on the worksheet where you have 3 numbers to add up in hex. But I don't want to do that problem for you, so I'm going to just change it around a little bit and just kind of use this scratch paper over here. Let's come up with a hex number. What's the biggest 3-digit hex number you could come up with?
2.
FFF. It has 3 digits, 3 hex digits. FFF is like 999 to a hexonian person. I don't know. And then let's add FF to that. Whoa, we're getting nasty. And then let's just add a simple smaller number like AF. Now let's put a real number in there like 2. Like a real digit that we're used to. Now this is going to be messy. Let's begin. F plus F, oh, I lost my cheat sheet. My cheat sheet said that A is equal to 10 and so on. Got to do that quickly because otherwise it's going to be really hard to do in my head. There might be a group of 2 here to carry. I was hoping for that. 15 plus 15 plus 2, because that's really what this ones column is doing. 15 plus 15 plus 2 in my head is 32. But you can't put 32 down here, and you can't do a 2 and carry a 3. No, you have to ask yourself, how many groups of 16 can you pull out of 32? 2 groups of 16. So you put a little 2 up here, and you're left with 0 remainder, coincidentally. I didn't mean for that, but that's just what happened. And now we're ready for this next column. Adding 2 plus F plus F plus A. Try to do this in your head with me. 2 plus 15 is 17. 17 plus 15 is 42. 42 plus A is really 42 plus 10. Oh, the total answer? I was taking his word for it. I couldn't do it in my head. John Quill did it all in his head and he got 42. I'm going to go on pause and verify that. Off camera, we did verify that 2 plus F plus F plus A is indeed 42 to a normal decimal person. How many groups of 16 can you pull out of 42? Either use long division or just wing it in your head. Yes, 2 groups of 2 is 32. I could do that in my head. We're left with 10. So the 2 groups of 2 again leads to a 2 carried to the next column. But you're left over with 10, which is really the letter A in hex. So it's crazy looking, but you put an A down here in your final answer because of your cheat sheet. That 10 is really an A in the final answer. And now this next column, which is your, what is 16 to the 3rd power, Tristan? Whatever that comes out to, that's what we call this 3rd column. You get back to me during this video. Tell me what 16 cubed is later, Tristan. Okay, for now though, folks, what's 2 plus F? Well, that's really 2 plus 15. How annoying. That's 17, which is not illegal. It's not on my cheat sheet. So how many groups of 16 can I pull out of that? 1. So we have a 1 now in this new column. We have a leftover 1, coincidentally. So we put a 1 down here in this 3rd column. And this 1 that's in the 4th column, that has no all imaginary zeros below it, it comes down here as a 1 there. The weird answer to this made-up question is 11A0. Don't pronounce it like 11A0, because then you're mixing and matching words. Just say 11A0. If you want to, put a little base, little subscript there in your final answer. I know in this section of the worksheet that all these numbers are hex. So you don't have to put little 16s to annoy me on every answer. But if the context isn't sure, like on the AP exam, read the directions closely. They like to trick you once in a while and make you read closely to know that your final answer is either hex, octal, or binary, or decimal. Those are the 4 number systems that you need to know for the AP exam. Okay, Tristan, this 3rd column, what is it proper to be labeled as in hex?
4096.
This is the 4096th column. Yeah, well, that's the way to pronounce it. Now, what is 16 to the 4th? In other words, what's 4,096 times 16? Okay, after deliberating off video, we agreed that this fourth column in from the right in a hex number, like the placeholder, that place for the 1 there, is the 65,536th column. That piece of trivia might win you $1,000 on some game show someday, especially if you can do it in your head with Alex Trebek, there to give you the award. Good luck, and do the rest of the worksheet for homework, please.